Hi, today we're looking at molar mass conversions for compounds, not elements. A little bit more, but a lot more of the same, including from things like dimensional analysis. So we first need to have the correct chemical formula. If we don't have the correct chemical formula, then things are going to be all messed up. Remember, if it's only the element, then it's the decimal number under the symbol on the periodic table, the average atomic mass, that's the decimal there. However, when we have a compound like magnesium chloride, we can see we got 1 magnesium and 2 chlorine. We multiply those values times the molar mass, that decimal. So 1 times 24.31, 2 times 35.45, and then we add the two values together. That gets us our molar mass. So again, when you're asked for molar mass as the only question on the test, I want to see this level of work. When we utilize it in a conversion, you don't need to show this work. So I'll again show you examples of that. But for right now, we have ammonium sulfite. We have, because of the subscript here, 2 nitrogens, 8 hydrogen, no written subscript means 1 sulfur, and 3 oxygen. So all of our multipliers times the molar masses added up, 116.17 grams per mole for ammonium sulfite. Aluminum oxide over here, a little simpler, 2 aluminum, 3 oxygen. Multiply those times the molar masses, gets our 101.96. So molar masses are dependent upon the chemical formula, not the number of atoms that are present, because this one has many, many more atoms than this, but is only slightly heavier. So you give yourself a try for these two, pause it now, and come back and see the solutions. All right, welcome back. Let's see how you did. So you've got one of each, scandium and oxygen, added up. 1 tungsten, 1 chromium, 4 oxygen, added up. Right, let me know if you have questions on that when you come in. Next, we're going to be looking at how do we do the same thing we did before with elements, but now with a compound. Well, if we're going from mass to molecules, we're going from mass to particles. So we start off with our mass. We write our unit of particles on the far right. Because we're dealing with mass, we're going to need molar mass. Now you can see this is a compound, so you want to calculate that on the side, but you don't need to show your work for it. The correct molar mass for carbon dioxide is 44.01, and because we have moles on top, moles needs to go on the bottom to convert it to molecules. So that's why we would have that there. Because we have what's on top multiplied, and then divide by what's on the bottom, we get our answer, which is always going to be a pretty large number of molecules because, again, it's a large number to start with. But yet again, dimensional analysis, same setup as we had when we were doing conversions back with elements. In the reverse, we're starting off with a mass, trying to get to formula units. I give it the unofficial abbreviation FU. The only time you can tell a teacher FU and probably not get in trouble. But this is formula units. We can't abbreviate molecules because that would be moles, or M, which is meters. We just got to write out molecules, folks. So we have mass. We need to calculate the molar mass of calcium nitrate. Again, you do that on the side. Equals 1 mole. We have our Avogadro's number of formula units, our particle, divided by the 1 mole of calcium nitrate. Multiply everything across the top, divide by the bottom, gives us our so many particles of formula units. Likewise, the reverse, if we're starting off with molecules, we want to find grams. Molecules on top, which means molecules on the bottom. Avogadro's number goes with the particles. And because we have molecules on the bottom, moles needs to go on top, which it's 1. Because we have moles up top, moles needs to go on the bottom, which again, moles has 1. And because moles is here, we're trying to get to grams, so grams would need to be on top, and our molar mass for H2O is 18.02. Multiply all the values on the top, divide by the bottom. If we were stopping at moles, we would just have this first one, right? If we were stopping at moles, we would just have this first connection. So again, you need to understand where you're trying to go to how far you have to go. Maybe you only need 1 step, maybe you need 2. That's what the units help you find. So come in with questions. We're going to go over do some practice. and you should be proficient shortly thereafter. All right, take care.